Welcome to the General Chemistry 1 class. This section is about chemical reactions and chemical equations, focusing on mass conversion of chemical reaction. In this lesson, we will interpret the meaning of a balanced chemical reaction in terms of the law of conservation of mass. Balancing chemical equations is necessary since chemical reaction they represent are governed by the law of conservation of mass. If we can recall, the law of conservation of mass states that matter cannot be created nor destroyed. In a chemical reaction, the mass of the materials before and after reaction is maintained. Looking at the combustion of methane, we can see that all elements found before combustion are still there after the reaction. As you can see on the picture, for methane and oxygen, the same after combustion, we have carbon dioxide and water. Looking at the molecular view, you can see the same number of hydrogen, which is 4 before combustion, and after combustion, it has 4. And 1 for before combustion, 1 for 1 carbon, and after combustion, you have 1 carbon. And before combustion, you have 4 oxygen atoms, and after combustion, we have the same number of oxygen atoms, which is 4. To illustrate in another way that chemical reactions obey the law of conservation of mass, the total mass of all reactants must be equal to the total molar mass of the products. Given our previous example, the corresponding chemical equation for the combustion of methane is given as methane plus oxygen producing carbon dioxide and water. If the equation is not balanced, we can see that the total molar mass of the reactant is not equal to the mole of the products. If we can now consider the balanced chemical equation for the reaction, in which oxygen and water have a coefficient of 2, we will see that the total molar mass of the reactants is equal to the total molar mass of the products. As you can see on the diagram or in the picture, the total molar mass is equal to 8.042 grams per mole. Is just the same with the total molar mass and the reactant, which is 80.042 grams per moles. Let's have an example to illustrate the chemical reactions obeyed by the law of conservation of mass. Burning a barium occurs accordingly on the following equations. 2 moles of barium plus 1 mole of gas producing 2 moles of barium oxide. Question number 1. What is the molar mass of the gas? Question number 2. Which of the following is the identity of the gas? O2 or O3? Before, in our previous lesson, we talked about stoichiometry, and again, they are talking all about the molar mass. So now, you must recall the concept of the molar mass so that you can connect in the chemical reaction, especially that we are dealing with calculations. Let's have the solution. To answer the question number 1, let us consider the law of conservation of mass. With this, 2 times the molar mass of barium plus the molar mass of the gas equals 2 times the molar mass of barium oxide. Barium has a molar mass of 137.33 grams per mole, while barium oxide has a molar mass of 153.33 grams per mole. If we let X equals the molar mass of the gas, the equation becomes 2 times 137.33 grams per mole plus x equals 2 times 153 grams per mole. Solving for x, we have 32.00 grams per mole. For number 2, we have two methods to deal with the problem. For the first method, calculate the molar mass of the given choices. The gas with the molar mass closer to the calculated molar mass is the identity. O2 has a molar mass of 32 grams per mole, while O3 has a molar mass of 48 grams per mole. The answer is number 1, is grams or 32 grams per mole. So the identity of the gas is O2. Method number 2. Method number 2, by inspection of the chemical equation, we can